society, and that's a good thing.
That's
Yeah,
so
what?
fantastic.
You can brag about me being like.
You got it.
A rap star.
Wait, so
I'm there, and you have.
Are you gonna be a rapper?
Yo.
Or are you gonna
wait,
be like
so do like taxpayers pay for people's retirements?
Well, no, I put into it, but the tax pays because I'm a state employee. The taxpayers pay for police, fire, teachers,
Oh,
government workers. So people say, dude, I don't pay taxes, then you're gonna pay some taxes. But the funny thing is when I have people say, hey, I pay for your wages. Well, I also pay taxes, therefore I also contribute to your wages. So, yeah, but it's just funny. It's like, oh, I pay your wage. No, the check didn't come directly from you, and if you want here's your 15 cents back. So.
we should go to the .99 soda shop.
Yeah, it's still up. I saw that sign the other day.
I saw, but I wasn't sure. I was gonna do it the other day, but I was gonna be late.
I
To
love
class.
I'm gonna do it. And I'm gonna.
I didn't have a
Go ahead,
penny. I
record.
only had a quarter, and I didn't have change for 24 cents.
All right, problem number 1 says solve for y. Problem number 1 says solve for y. So I think the answer, help me out, I might be able to do it. Is it y equals, am I right so far?
Yes.
Okay, good. Y equals 10 minus x, or
Yes.
negative x plus
Yes.
10. Is that right?
Yes.
Oh, did I do that right? So problem number 1 has an answer of, what? What did I say?
Y equals 10 minus x. Or
10.
negative x plus 10.
Negative x plus 10? Or, yeah. Okay. Problem number 2, I think I could do number 2. It looks like y equals negative 3x plus 9.
Yeah.
Did I do that right? Okay, problem number 3. I think it's going to be y equals, let's see, half x
Plus 1.
plus 1. Is that it?
Yeah.
And remember that when I said the best way to do it is distribute first, and then so to distribute you got half x, and then half of negative 6 is negative 3, and then you add 1. And then number 4, we're solving for y. Number 4, let's see. I'm going to clear the denominator, so this is the first step I'd get here. What did I do to everything on that problem? I multiplied everything by 2, so what that did is it made the 3x a 6x, it made the 4 an 8. And then I'm solving for y, so then my last step is doing this, or I could have it 8 minus 6x, but that's a little more preferable. Are we okay up through number 4?
Yeah.
May I move off the board?
Yeah.
Everyone feel good? All right.
Wait, what'd you get for number?
It's right there.
Wait, how'd you get negative 6?
Because I would have done this.
You got 2 and 3 half x.
So the very first, the 6x plus y equals 8 was I multiplied everything by 2 to clear the denominator.
I got 3x. Wait,
Did
hold
you
on.
forget to multiply
Hold on.
that by 2?
For number 4, it said 3x minus 1 half y equals 4.
It's 3x plus 1 half y equals 4, right?
Yeah.
So then I multiplied everything by 2. So I got 6x plus y equals 8, and then I moved it. Number 5, we're solving for y. Let's see. So the first move on number 5, I would have had this, right? And is it solved for y at that point? No, it's solved for 4y. So what should I do to all 3 terms? Divide everything by 4. Good. All right, so that's y equals reduce where needed. Is that good?
Yes.
Front side's good. Are we set? Solid? Feel all right? Yo.
Does it matter, like, if you just do, like, really long lines and all the ends before? Or do you have to do, like, it's the same thing, right?
You mean if I did this?
Yes.
Yeah, and then break apart the fraction. But I guess if you did that, then you could have, you could have left it probably as a big old fraction, or you could have broken it into the 3 components. All right, I think I'm ready to move to the next board. Can I do that?
Can
All right, solving for y, number 6. Let's see, solving for y. My first step is this. What do you think? So what I did is I just moved the 3x over by subtracting. And then what should I do? Divide everything by 9. So y equals, reduce where needed. 2 minus 1/3 x, that works as well. I like it. Number 7. The first step I'm going to have is this. Tell me what I did. What did I do?
You combine the things.
I distributed the 1/3, so I 1/3 times x is 1/3 x. 1/3 times 20, negative 27 is negative 9, right? And then I need to solve for y, so I'm going to add 3 to both sides. Is that right?
Yeah.
Sweet. All right. Number 8.
We did number 8 in class.
Oh, we did?
Yes.
Oh, cool. So watch the video. It was done in class. Did we do number 9 in class or just number 8?
No, we didn't.
We just did 8?
Yeah, we did 8.
Everyone feel good? We feel good? Aiden, I did number 1 as well.
Oh, wait, maybe it was 8 and 3.
Okay.
I think it was
Thanks for reminding me because I would have forgotten. I would have reworked it out. Boy, if you saw the same problem worked out twice, what would that have done to you?
It would have made us lose our learning.
Kids might have started crying. All right, let's see. I'm gonna write this one out. Let's see. I have this. This is similar to number 8, right? All right. Bless you. So we have y on both sides, correct? So I need to start moving things back and forth. So we'll just start this problem. So I might choose to say, I'm going to subtract 4y. Might you have chosen to do one step a little different? Yes. What should the outcome be the same? So then I have this. Okay. So now I have a y just on the other side, which is great. So then I could probably say, well, let's add 11 and subtract 4x. So that clears that and that. So I have 2y over here equals, what is that? Negative 2x plus 2. And then divide everything by the 2. So y equals negative x. That's a 2 plus 1. Is that right? Shoo, man. All right, and then number 10, last problem. What do you feel? 10, last problem. So my first step is this. So what did I do to get to that point? What did I do? That's the first step. What did I do? Yeah. Yeah, I subtracted 6x from both sides. And then I'm going to divide everything by negative 2. Remember to bring the negative along. The big error is people don't want to bring the negative for whatever reason. And that right there is good for us, right? Gentry, did you just put your name on this one? Oh, so I have not put this in the grade book. That one, there's your grade on that one. And then you don't like putting your name on stuff. Okay, I got that. And then that, cool. And then she's not here. Thanks, man. All right, let's go ahead and hand forward your homework. Make sure your names are on it, Gentry. And make sure your names are on it. And we're going to, so things to think about, so today we're going to be working a little bit on worksheet 11B. Let's see how much we can get done. I'd like to go through and, have you guys generate all the odds for me. And then hopefully that gives us enough time that you get a good start on the evens. Okay? Cool? And then tomorrow we have a practice test, which is in your book. Yeah, it says practice test. And then on Monday we have a take-home test, which will be similar to the practice test, which means you can work on it and then you submit that on Tuesday. And then Tuesday we'll have our actual unit test.
Wait, does the practice test count as a grade?
Yeah, I'll count it as a grade. I mean, it's not good. Like if your test is worth 50 points, your practice test isn't going to be worth 50 points. It'll be worth some towards the test, but not like.
How much is a take-home test? Like points.
It's kind of nice when people are listening to the whole story. It'll be worth a smaller amount than the actual test, but it'll be going to the test category. So if the test, I'll just give you an example. If the test is worth 50 points, the take-home part will probably be worth 10. that make sense? Yeah.
Are there gonna be like absolute value on this?
Yes.
We didn't do that very much.
Well-
We did that for like a day.
I know, but we'll make sure we focus on it tomorrow as well.
And you said that you didn't like it.
Well, I didn't like the absolute values on both sides. And the reason I don't like the absolute values on both sides is an absolute value graph looks like this. It also looks like this, depending upon. So weird things take place when you have an absolute value equals an absolute value, because you could technically get something like that, which means then all of a sudden you have these as your answers, and if this is your x-axis,
So this is not gonna be on.
There's no intersection.
no. So the answer would take place here, and the answer would take place here. But sometimes it's hard to detect that on an absolute value, especially in that situation. So we made an error putting that type of problem, absolute value on both sides.
So it's only gonna be on one side.
Yes.
Okay.
You're solid? Sweet. All right. Let's see how we do. Problem number 1. I need somebody. We are solving for y. Who can I pick on? Gentry! Go ahead. Do what? Add 9x, because I'm solving for y, right? And then I get 3y over here. Those cancel. That gives me 9x plus 24.
Why wouldn't it be 24 plus 9x?
It could be that as well, but I have to pick one or the other. It's actually more accepted to do letters than numbers, but they're both correct. All right, Gentry, can you lead us home on this problem? Divide 3 on both sides, which means I'm dividing everything by 3, correct? So that's going to cancel. That gives me a y. I reduce this to give me 3x. I reduce this to give me 8. There's our answer. Bless you. I bet you might have the opportunity to start getting number 2 done. I'm going to start writing number 3 up on the board. If you wanted to get number 2 done while I'm writing number 3 up, awesome. Did you guys get 18 for number 2?
Yeah.
Sweet. Negative 18?
Oh yeah, you divide by
No,
negative.
no, that's right. It's negative 18.
Yeah.
Thanks. Thank you. Sweet. So we'll work that out at a different time if you need it. But you know what the answer is? Negative 18 I agree with. But we're not there. All right. Gentry. Who should I pick on next? Well, actually, do this. Do this for me. Give me a number between 1 and 23. That's a whole number, not a fraction. 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, solve me for y. Ready? Alec, right? Yeah. Okay. I want to solve for y. So I got to start someplace. What do you want to do? Okay, so are you saying that because you want to bring the y over on this side? Eliminate the 4? Well, the 4 and the y are being multiplied together right now, right? So I would have to go and start dividing, but I don't think we should do that yet. I like your thinking, though. And I think it's okay if we keep the y over here. So if I want to keep the y over here and start moving everything else over there, what would make sense?
Subtract 9 from both sides.
Perfect. Subtract 9 from both sides. All right, so that gives me 3x here. Is that right so far? And then that's minus 4, I believe, equals negative 4y. Okay, so it looks like we have moved towards starting to get y by itself, which we need. Alec, what else should we do? How are the negative 4 and the y being held together right now? Well, it's negative, so the problem's negative. But if I didn't have that right there, well, how would the 4 and the y be held together right there? There's not a plus sign, though. A letter and a number right next to each other are held together by multiplication, okay? Okay, so that's being held together by multiplication, and ready? So is that. So what undoes multiplication? Division. What do you feel I should divide all three terms by to get y all by itself?
4.
You're really close. Why am I saying you're really close on that one? And that's a huge error a lot of kids make. What are you missing? What's with the 4?
Oh, -4.
That's it. The negative. Okay? So divide everything by -4. And then I can keep the y over there, which is fine. That gives me -3 over 4x. And that gives me, what's -4 over -4?
1.
Positive 2. All right, so some people are like, okay, I'm done. Other people get bothered that the y is on that side. So then you can just take the whole problem and flip the whole thing over. And there's the answer.
Wait, will you accept it if the y is on the other side?
Heck yeah! I like it. So someone's all stoked going, dude, there's 2 different answers I can give. I got a chance. All right. If you want, start working on number 4. I'm going to start writing up number 5 on the board.
Super fast. So do you just divide 5 to
Well, I don't know. I'm not reading. Don't start working on that one because that's got a little trick to it. I want to make sure you see it.
What one?
7.
Oh, I know what it is.
Oh, I see.
Is that right for number 4? I tried to do it in my head.
Yes, it is.
Okay. And if you have a question on that, we'll take care of it a different time. So, number 5. Alec, I need you to give me a number between 1 and 22. That's a whole number. 9?
No, 19.
19.
Oh my God.
You pick. Which side of the classroom would you like me to start from? That side, or the middle?
Middle.
Or the front, or the back?
That side,
Oh,
that side.
your choice. Your choice. That side, 19? 19 you said?
Don't worry.
Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18.
I literally called it.
Literally.
You're welcome.
All right, sunshine. All right. I literally did. Okay, this is a great problem. Why is it great? Well, 1, you have it. And 2, what special new way to do math have I shown you to get rid of fractions? What would I do? Yeah, so what am I going to multiply everything by? 5. How many terms are up here right now? There's 4 terms. So if I want to get rid of that denominator, because I don't like fractions, if I multiply this by 5 and this by 5 over 1, 5 over 1 is the same thing as 5, correct?
Yeah.
And that's 5, and that's 5. All right, so 15 plus, is that just y then?
Y.
Okay, and that's 10x.
10x plus 20.
Okay, keep going.
Minus
Shh. Subtract 15. Subtracting 15 from both sides.
5.
Plus 5. Sweet. There you go. So here's the nice thing. That if you, bless you, if you start seeing that whole fraction thing, you can really make these problems pretty easy without the anxiety of a fraction, which I like, okay? So if y'all want, go ahead and start on number 6 while I write number 7 down. Is that okay?
Yeah.
Okay. I don't know. No, you wouldn't. See it right away. Yeah. Totally, yeah, I like that. Same answer, right?
Yeah.
Sweet.
Oh, cool, Abby.
I think that's the answer to number 6. Did I do that one right? I think.
Yes, you did.
No way.
Oh, these are when it gets.
I got mine.
I know how to
Oh
do
wait,
them.
it's 18x minus.
Well, not yet.
18x minus 18x? Or 18 minus 18x?
Yes.
Wait, I got a y equals negative 12 plus
What's that?
I got negative.
No, I got it.
negative.
18
Or, I mean,
minus 18.
positive.
Hang on. I did it in my head, so I might have goofed things up.
You did
No,
it.
you didn't.
Okay, if I subtracted,
Hold on.
okay, if I multiplied everything by 3, I'd get 30 minus y equals 12 plus 18, right? Right, and then I'll divide, hang on, too many people are asking me stuff, I'm trying to work through. All right, so, hang on, number 6, let's see. Can I do this? Is that all right? So that, all I would have done in that step is multiply everything by 3. That's exactly what I had done on number.
Would it not be negative 3?
Well, no, you're right. But can I keep this sign here?
Yes.
If I keep that sign there, that's fine. If I multiplied everything by negative 3, that would have been a negative 30, a plus y, a negative 12, minus 18x. And then at the very end, it would have gotten the same answer. So it looks like if I subtracted the 30, that becomes negative 18. Then I multiply everything by the negative so that this is correct. All right.
How did you get negative 18? Because if you multiply a positive 6x by 3.
Because you have to divide it by negative 1. Which is negative 1.
Right. We had the negative y. All right.
Now just to teach us number 7. Division on top of the fraction.
All right, Abby. Give me a number between 1 and 22. That's a whole number.
Oh, 23 and 27.
Okay, good. Between 0 and 22. Good.
Just round it out.
1 and 22.
Oh. 21.
21. You want me to start on the left side, the right side, the back, the front, the middle? You pick. Wait.
That one.
That side.
Is she
21.
gonna
She's
land on
gonna
you
get
again?
picked again, yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
Oh.
Oh, that's me.
You.
Oh, I know how to do
you're
this.
right.
All right, so we're gonna try and get you to work through it. You ready?
I did it right.
You ready?
I'm ready.
Okay.
I did G
What?
equals
What are we trying to solve for? Which letter?
X.
We're trying to solve for the x.
So I took it out.
Okay.
Yes.
Okay, so hang on. This is what we're trying to solve for.
Yes.
But I have 2 of them, right?
Yeah.
Okay.
Okay.
What do you
so
think?
I did it, put
Shh.
it in parentheses and did 4 plus 5y and
Oh.
X on the outside.
My gosh. So you undistributed? Is that what you just said?
Yeah.
I don't get it.
And then
Woo!
I don't get it.
What the heck?
All right. Hang on. Shh.
and then
All right, hang on. You're good. So hang on. Let's think about what just happened. Could it happen? I just ran and gave a high five. Okay. Does everyone agree that there's an X in both of those? Everyone's with me at that point.
Yeah.
Anyone like, oh, dude, no, I don't know. All right. So think about what we just did. If I were to go X times 4, what would I get?
4x.
4x. If I were to go X times 5y, what would I get?
5xy.
5xy. So being I had here and here on both of these terms, if I pull both those terms out and group this, does this appear to be the right thing to do so far?
Yeah.
Okay, so think about the math that you know. If you distributed the x over, you would get the original problem, right?
Yeah.
So if I undo distributing, so I'm like kind of finding it in the common factor and I'm pulling it out. It's kind of called something called factoring. I'm factoring a factor out. Okay. Does everyone feel comfortable with that so far?
Yeah.
Okay, now, hang on. How is x and 4 plus 5y being held together right now? Held together by multiplication. So if this and this whole thing are being held together by multiplication, what undoes multiplication? Division. So what would you feel I should divide both sides by? Yes. Oh, that's dead. So if I divide this by 4 plus 5y, and I divide this by 4 plus 5y, so this is going to cancel this, and I'm going to have x left over here, and then I'm going to get g over 4 plus 5y.
I don't get it.
Or I could,
Talking to you, Steven.
no, this is a big concept. There's a lot of people. I'm gonna spend a few minutes on this, okay? Because this is a different way of thinking. It'd be like your elementary school teacher saying, okay, we have multiplication, and then all of a sudden you never touch fractions. Okay, so we have to teach you the do and the undo. So what happens here with this problem is this. Okay, let's rewrite the original problem.
Oh, okay.
So here's the original problem. You good? Come if you're wrong. I'll make you understand this. You good? Now, questions that might arise with a student. Oh, I could just add 4x and 5x together to get 9x, which a lot of students would go to right away. Okay, and that's kind of a legitimate way to think, but what does the 5x also have tagged in with it? A y. So do you now agree that 4x and 5xy are not like terms? Does that make sense if I said that? Okay. So then we have to say, well, if I can't add those together, there's got to be something else I could do to this problem. Okay? So there's a few other things that we could look at. We could say, what would happen? Did I change the problem involved doing just that? No. Does that make sense? I just put parentheses around the right side of the problem. Did it change the problem? Did it become all of a sudden like, the color yellow? Nothing changed, right? It's all the same. Okay? So then we have to start thinking, okay, now if I have parentheses in place, if I undid parentheses, like if I undid distributing, is that something to be do? Now, some people might say, well, okay, well, why can't I just have a 4 taken out, which is great, which gives me this, and you're like, huh? So if I factored a 4 out, I think most of you agree with that, because 4 times x is 4x, right? Well, watch this, ready? 4 times 5 over 4 is 5xy. Okay? So that's not really the right thing to do. I mean, but that's a thought. And then, hang on. And then other people might say, well, what if I just factor a y out?
That's 4y.
Why not just do 9x plus y?
Okay, well, I'm just showing you. These are some things that could take place. If I factor a y out of both, if I redistribute this, y times this, the y's cancel, which gives you the 4x. If I go y times this, that gives you 5xy. But that still doesn't help us because we still have this x problem. And what I was doing is seeing if we could put together the x somehow. But these, if I was here, those are unlike terms because you have x, y. These are definitely unlike terms. So I'm going to eliminate that thought. Okay? So just practicing through this problem a little bit will allow you to start realizing I know I can't add those together. Put a question mark. That does not work. It doesn't work because they're not like terms. So there's got to be some other things to do. Now, this last part, keep your hand down because I'll get you. So let's take a look at this. This is our original, right? We're going to bring it down here. Okay. What did I just do?
You just separated them.
You got the square root of 4, and then you just did 5 times x.
So think about what I just did.
You break it.
Everyone agree? G to G. Same thing, yes? Why? How is 2 times x the same as 4x? 2 times 2 is 4. 4 times x is 4x. Yes? Hang on. Now, I can't really break 5 down. 5 is just a prime number. So 5 times x times y is 5xy. Yes?
Yeah.
So does everyone feel comfortable that g equals 2 times x plus 5 times x times y is the same thing as g equals 4x plus 5y?
Yeah.
Or 5xy?
Yeah.
Does that make sense?
Yeah.
Okay. So now, if we take a look at this, I'm just going to take a look right at this section right here. What do I have in common between the terms? Is there a 2 in common between all the terms?
X.
Is a 2 in common between the terms? No. Is a y in common between these terms?
No.
No. What do I definitely have in common?
X.
I have this and this. So now I'm going to take those x's and bring them outside. Okay? Now I have to group it because I'm undoing it. What do I have left here? I have a 2, a 2, and a 2 and a 2. What's a 2 and a 2 multiplied? 4. What's a 5 and a y multiplied?
5y.
Okay, that's all I did. Okay, I just wanted to show you a different way of approaching it, where you're thinking about it, what's really taking place with the problem. This is at a very basic level, saying I'm taking it down to its most prime components, its smallest components. We're taking it down to its genetic code. Yeah.
Could you just divide y?
If I divided by y in the beginning, that would have given us something like this. So if I divided by y in the very beginning, this would have happened.
Oh, because they would be to the other ones.
Mm-hmm.
Okay, got you.
But that's a thought. But that's a hard thing. And a question over here, Steve.
Oh, well, it doesn't matter anymore.
Who does?
Because you.
Because you hate me?
No, I was just saying, like. No.
Does it make sense how I started breaking things down? So I
Yeah.
answered the question you had?
Yeah. Well, I mean, how do you know where to put the parentheses?
Okay, so the parentheses I could have put in the very beginning of the problem. Like I could take any problem all day long and start putting parentheses around each side. It doesn't change the problem at all. It's like having x and then having 1x. Yeah, x and 1x are the same thing.
Yeah.
So we could put parentheses around each side of the problem all day long, and it doesn't change the whole dynamic of the problem at all. Is that right?
Yeah. Cool.
All right, so that was a lot different thinking problem. Okay? And so should you have mastered it at this very junction when I just showed you it off of a homework problem? No. Okay, so it's something that we're going to probably refer back to. We're going to come back to from time to time and make sure we hit it.
Is this gonna be on the test?
I could be.
Oh.
Okay?
Hey, you
So
know-
let's do this. Let's go to number 8. Because number 8, guess what? We have the same type of thing. Okay? So let's think about what we did. Now, item number one, can I subtract 4ax from 9x and get it put together? No, because 4ax is different. It's not like terms with 9x. Now, if we just had 4x minus 9x would give me negative 5x. But this a goofed up our whole thing. So let's back up a smidge and say this. Is this do you all feel that's good? And this is an A. This is an A right here. Take a look at that. Does it make sense, me going from the red to the black as far as breaking down the prime components?
Yes.
Well, I just want you to see. Do you agree that's right? Like if I went 2 times 2 times a times x, do I get 4ax? And if I went 3 times 3 times x, do I get 9x?
Yes.
Everyone's good.
But we
Okay.
can do the fraction.
Let's not worry about that yet. I'm just trying to show you the very smallest components of this problem. This is the little nitty gritty. This is all holding together. So I have These terms all being held together with a multiplication. These being held together with multiplication. So if I take a look at here and here, what do I have in common between the two? I have an x in common. So W is just coming along for the ride. I have an x in common here. Now I'm going to put this in parentheses. I could have put this whole thing in parentheses as well. Okay? So if I had an x in common here, now I'm left with 2, 2, and a, which goes right here. What's 2, 2, and a? 4a. The minus sign comes down. And then, remember, I had an x in common here, so that's now out front. Now I have a 3 and a 3 in common, so what do I have here? 9.
Wait,
Okay.
so the x goes away when you distribute it?
It's not going away. You're like pulling it out front. So watch when I distribute. If I were to go from this step back to this step, I'd go x times 4a. X times 4a is 4ax, right?
Yeah.
Minus 9. So if I go x times negative 9, I get negative 9x. So I just kind of undid distributing. No. I don't have to distribute because what am I trying to solve for on this problem? X. So now I'm getting x kind of by itself. So someone might say, hey, let's divide both sides by x. Well, that gives me w over x, which is not going to help. But this and this are being multiplied together, right? So if I undid this by going, I'm going to divide this side and this side.
Oh, I get it.
Watch, this whole parenthesis goes with that whole parenthesis.
So you technically just bring all the other numbers over.
I'm dividing it as a whole term. And so then I wind up with an answer of x is equal to w over 4a minus 9. Now, can we drop the parentheses? Sure. Can we put them back in place? Absolutely. It's your choice. Yeah.
But you said that we have to do, you're saying that we do it as a whole term, then isn't x a part of the 4a minus 9?
But, okay, I like what you're saying. Okay, so let's kind of, over here, we're going to do, if I have 4x, that's the same thing as 4 times x, right?
Yeah.
Okay, so if I divided both sides by x, and I had another side that I divided by x, I don't know what's over here, I could do that and that cancels out. Now, if I had 4 and then x plus 2 equals something over here, I can divide both sides by x plus 2 as a whole term. It comes as a whole term, as a whole unit. That cancels out. I could have also said, let's divide by 4, and I could have had x plus 2 equals question mark over 4. Okay, so there's just different ways to manipulate it.
So we could divide everything by x.
If you chose to, in the very beginning, divide everything by x, you would have wound up with this. And now I have a denominator with our letter we're trying to solve for.
So that isn't the solve for.
So we could indeed get there from here, but now we've gotten to something that we all hate, fractions. We have a fraction. So by us doing that, we created a fraction. And now we have to solve the fraction. So we want to solve for x by itself. Well, we have a w in the numerator now. And then people might say, well, what happens if we divide each side by w? Well, now I get 1 over x is equal to 4a minus 9 over w. If I took the reciprocal of both sides, so I flipped over both sides.
Okay, that's too complicated.
No, just flip it over. Flip 1 over x over, I get x. Flip 4a minus 9 over w, flip this over, I get. So it's another way I could have approached it, a different way to think. But you know what? Your brain might see that blue way. That might have been like, oh yeah, I'm there. Where like other people are going, do. I'm set here. But everyone's brain works a smidge different, and that's awesome. We want it to be like that. Because we're all the same, we'd be boring. But everyone's mind works in its own beautiful way. And so some people might see this, and again, we had said it a long time ago that math, all math is a way of teaching you how to think at a higher level. and your higher level might have taken this path to get to that, and someone else might have done this path, and someone else might have done this path, and that's the synaptic response that's taking place in your brain. Okay? Guys and girls, so worksheet 11B, I will go over and check off tomorrow. So I'll check it off first, so let's make sure it's done, okay? Everyone feel good about that? We covered some tough stuff. The videos are here. So let's, realize you can go back to the video. We just did 40 minutes worth, so